Okay, so Assalamualaikum dan juga selamat petang. Alright, so for today what we're going to look at, we're going to learn about chapter 10, which is about wave properties of particle. Okay, so wave properties of particle. Alright, so if you look on the picture, this is going to be the scientist that actually introduced this idea about the wave properties of particle. So what does he said? He said that it is going to be a phenomenon where under certain circumstance, a particle will exhibit wave properties, and under other condition, it will be a wave exhibit properties of particle. What can we understand is that at a certain time, there is a time that particle become a wave, and there is a time that wave become a particle. Right, so from here what we're going to learn, okay, the first learning outcome, we need to state the wave particle duality, and also we need to use the de Broglie wavelength equation in order to solve the problem. So supposed to be the equation is lambda is equal to h over p, where lambda is going to be the wavelength of the light or the wavelength of any particle, h is going to be Planck constant, and p is the momentum. Alright, so from here, we know that how does the de Broglie got his equation? Well, he expand the Planck quantum theory, where Planck said that the energy of the photon is given by E equal to hc over lambda, and since the photon move with the speed of light, therefore from the theory of relativity, E equal to mc square, and mc is equal to a momentum. We know that generally the formula for the momentum is going to be mv, but since we are talking about the photon, so photon move with the speed of light, so v here equal to c, so it's going to be momentum equal to mc. So this is going to be momentum for the photon, momentum of a photon. So energy for the photon is also equal to PC, momentum times with the speed of light. So what they do, they got 10.1 equation, and also they got 10.2 equation. So these two equation being equate, so we have here hc over lambda equal to PC. So cc can be cancelled off. So from here, de Broglie got another equation where momentum is equal to h over lambda. P is going to be the momentum, and lambda is the wavelength. Okay, so from here what we can say, so this is going to be the derivations of the de Broglie equation. So this is what the de Broglie shown, okay, or this is going to be the de Broglie equation. So from this equation, what is so special about this equation? In this one equation, we have two kind of aspect. In this one equation, it have a particle aspect. Particle aspect is given by the momentum. So when you are talking about momentum, momentum is only belongs to the particle. So particle have momentum. So momentum is the particle aspect. And the wavelength, we always know that wherever there is a wave, there must be a wavelength. So the wavelength here is going to be the wave aspect. So within one equation, you have two kind of things. You have particle aspect, you also have a wave aspect. Okay, so from here, alright, so what does the theory say that? This case, so it said that the light has momentum and exhibit particle properties. So if you look on the equation, the light has a momentum, and momentum is actually characteristic for the particle. Okay, so means that even though we said that the light is actually a wave, but also light can be a particle. Okay, this also shows that light is dualistic in nature. So in a way, light can be two things. Light sometimes can be particle, light in other time it also can be a wave. Okay, behaving in some situation like a wave, and others like a particle, known as photon. This phenomenon is called wave particle duality. Duality means that dua alam lah. Okay, it got two kind of nature. Okay, so if you look here, this gonna be the evidence where the light can actually become two things. Sometimes it become a wave, the other time it become a particle. So if you look here, when does it become a wave? In Young double slit experiment and also diffraction experiment. When does the light become a particle? The light become a particle in photoelectric effect experiment and also Compton effect. Okay. So from this derivation, Louis de Broglie said that okay, the two aspects not only belong to the light, the wave particle duality or the two aspects also belong to the other matters. Meaning that other matters such as electron, proton and also other things might also have a dual nature. Okay, so the other things also might become two things. We also can become two things. We ourselves is a particle, but we also can become a wave. In a certain situations. Okay, when does we become a wave? When does we think? Okay, so from here, he proposed that any particle of momentum P should also have wavelength lambda. So any particle also will have two kind of aspect, momentum and also lambda. So this formula, lambda equal to H over P, is not only formula for the for the light, but this is also formula for the others matter, for all matters. So lambda is equal to H over mv is gonna be the formula for all matters. Okay, so from here, what we can say is that lambda is going to be the de Broglie wavelength, H is going to be Planck constant, m is the mass of a particle, v is going to be the velocity of the particle. Alright, so, okay, so this 10.4 is going to be the de Broglie relation. So equation 10.4 is referring to the de Broglie equation. Okay, alright, so this theory is actually being confirmed. So Davisson and Gamow able to diffracting electron, which is also shows that electron have wave properties. So in the year 1927, there is 2% that is actually able to diffract an electron. When you are talking about electron is actually a particle. But when electron can be diffracted, satu elektron boleh dibelaukan menjadi banyak-banyak elektron. So dia melibatkan sifat gelombang. So bermakna even though kita rasa elektron tu adalah satu-satu, tapi elektron tu juga at other time kita boleh membelaukan dia. Dia boleh dibelaukan. So apabila pembelauan berlaku, bermakna elektron juga boleh mempunyai sifat gelombang. Sebab hanya gelombang sahaja yang akan berlakunya pembelauan. Okay. So sekarang ni Davisson and Gamow able to show that actually electron also can have diffraction, can be boleh dibelaukan lah. Alright, so bila dia boleh berlakunya diffraction, maka elektron tu mempunyai sifat gelombang. Okay, so from here we straight away go to the next slide. Okay, there is example here, you can see by yourself lah. Okay. Alright, this is the tutorial. Okay, let's us